Hey there. If you've been keeping up with the news in the AI world, you probably saw this one from Databricks, where they announced DBRX, their new open source large language model. And I was going through their blog post, and I came across this chart, which is very similar to a chart that you'll see from from other model builders, where they actually take a bunch of standard benchmarks like MMLU, HumanEval, and GSM. And compare their model against other models, and show results. Now, the chart in the middle really caught my eye because the differences are really stark, and that's partly because they did a bit of a cheeky move and set the y-axis to start at 30%. But regardless of that, it's a pretty stark difference between DBRX and some of these other models. Now, these benchmarks and these results are how we're supposed to make decisions about which model to choose. But these benchmarks are fairly inaccessible to like an average developer like me who is new to the world of AI and large language models. And so if I have to get a sense of how this model is behaving, I'm left with really what's called a vibe check, where I try a bunch of samples, get a sense of whether they work well or not. But that's a very anecdotal way of evaluating or choosing whether DBRX or other models are actually fit for my use case. And so what I've been actually looking for is a way to combine the systematic nature of something like a standard benchmark like HumanEval with a more experiential nature of vibe checking, where I can actually get a feel for how the model is behaving and make a proper decision. And that's what this video is all about, right? I'll actually show you how can you actually dig deeper into a benchmark like HumanEval, so as to combine the systematic nature of it with the more experiential nature of like a vibe check, so that you can basically get the best of both worlds. And we'll also end up learning about some of these benchmarks. So we'll learn about how can we potentially make our own benchmarks by understanding some of these. And then finally, I also want to show you, how all of this can be done in a very productive and efficient manner, so that you can actually make like very fast iterations, very fast experiments, while you're trying to replicate some of these benchmarks, and do these things within minutes rather than days. Right. And for this last bit, I'm going to use Empirical, which is a tool that me and some of my friends have been working on. It's an open source framework for testing and evaluating different LLMs, and you can check us out on GitHub or the documentation website. But for now, I'll just actually show you a demo of how it works, and in that process, we'll actually learn about the HumanEval benchmark. Now, if we go further down in this blog post, we'll see a table where DBRX is compared against some of the other popular closed source models, and I'm actually going to use this as a reference point for what we're going to do in this particular video. So that's basically what we're going to do. Now let's start with just talking about HumanEval a bit, right? So HumanEval was actually announced as a benchmark by OpenAI in a fairly popular paper called Evaluating Large Language Models Trained on Code. And this particular data set is actually testing a model's capability for code generation. Right now, code generation is a very powerful capability, right? Because we've actually seen evidence on how being trained on code actually helps models improve their capabilities for reasoning. And that also has an impact on non-code use cases. So even if your use case does not involve generating code, this is a pretty relevant benchmark to keep an eye out. So I'm going to actually jump into my editor, where I've actually downloaded this particular data set, and we'll start by just taking a look at what this data set looks like. So this data set is actually a JSON-L file, and each line is a JSON object, and there are about 160 total objects that are there in this particular file. So 160 odd samples for us to test against. Now let's look at what each of these rows looks like. So I'll open the sample JSON where I've actually extracted the first line item, and you'll see it has a bunch of keys. So the first key is task ID, which is just a serial number. Then there's something called a prompt. Now if I just open this particular prompt for you in a different file, you'll see that this particular prompt is actually a definition for a function. And it's actually, the function is called hasCloseElements, which takes in a list of numbers and a threshold value. And it's supposed to check whether the list of numbers, are there any two numbers closer to each other than the given threshold, right? So for this particular given threshold, 0.5, we're checking whether any of these numbers are closer to each other than 0.5, and the answer is false, right? Now, this function is not complete, and the expectation is that a large language model will actually fill up this particular function for us when this is actually sent as a prompt to that particular model. Now, let's go back to the sample. So we went over the task ID, we went over the prompt. The entry point is just a name of this particular function that we're generating. There's also a field which is the canonical solution, which we'll actually ignore for now because we're actually going to ask the model to generate this for us. And then lastly, we have what's called as test. So if I open this particular bit for you in a different file, the test field actually has a bunch of test cases which are used to check whether the generated function is correct or not, right? So the candidate function is basically given a bunch of these test cases, and we're asserting whether the behavior matches our expectation. And if it doesn't, then this particular method is actually going to throw an assertion error, which will be an exception in Python. But if it just works silently, then these tests pass. So HumanEval, this particular sample, is a nice closed loop, right, where it gives you a problem statement, asks a language model to sort of generate it, and once generated, runs that on these test cases and see whether they pass or not. So this is what this particular data set is about, and we'll now actually try and replicate some of the results that we saw from DBRX by using Empirical and running this data set against a bunch of models. Now, to do that, I'm going to open this JSON file. So Empirical relies on this particular JSON file, which is called empirical rc.json, as a way to describe the particular the test that we want to run, right? So it's a declarative configuration which basically defines how you're supposed to run this particular test, right? And I'm just going to start and build this file so that you get a feel for how simple it is to actually set up a configuration. So the first thing I'm going to do is that I'm actually going to set up the dataset. So in the dataset field, I'm actually going to define the path for the particular dataset that we're going to use, and I'm just going to point it to the particular JSON-L file that we were looking at, right? And that's it. This is all I need to actually define the test cases that I'm going to run. Next, I'm going to define runs, which actually captures the models that I'm going to use to run the dataset against, right? So let's actually try and create a new run where I'm actually going to run this particular file, run this particular dataset on let's say the OpenAI 3.5 turbo model. So I'm just going to define the type as a model. There are other model types that are available, and you get auto completion to actually sort of observe some of that behavior. I can use a script and basically test a script which can represent a custom application that I might have made, or I can actually just use model which gives me the ability to just run the data set against an off-the-shelf model. Once I've chosen the model, I can actually now define the provider, and Empirical supports a bunch of different providers. I'm going to select OpenAI for this particular experiment. And I'm going to define the name of the model. So let's go with 3.5 turbo and get a feel for how that works. And I'm going to then define the prompt. Now we will be sending the prompt that was defined in the sample, but I do want to sort of add a few instructions to the overall prompt so that the model knows what we are expecting. Right? So I'm just going to say something like complete this Python function based on this function definition, right? And then after a bunch of new lines, I'm actually just going to use a templating syntax to actually refer to the prompt that's there in the sample file, right? And Empirical will automatically figure out that this is actually the prompt that I need to pick up, from this particular data set. Now, I've actually now defined, one such test. So let's go ahead and jump into the terminal window where I can actually now run this particular test. So to run this particular test, I'm actually going to use the empirical CLI, and the empirical CLI gives you a simple command called run, which actually picks up this configuration and runs it for you. So let's give it a few seconds. So it ran the tests. It ran about 164 tests on 3.5 turbo, and it was able to generate outputs for all of those scenarios. Now let's actually dig a little deeper into this and actually see what those outputs look like. So I'm just going to use a different command, which is the UI command, which will actually open the test results in the browser for me and show me this UI. So this UI actually lays out, the inputs and the outputs that were generated from this particular run, right? So I can see, this was the prompt that was sent. This was the output that was generated for the prompt. And I can actually take a look at, what the model was really giving to me. Interestingly, the model sometimes gives me, results that actually have backticks around them when it follows markdown syntax. But sometimes it just gives me the bare result. That's just some sort of nuance to keep in mind. Now, while I can use this to actually eyeball results, it's infeasible to actually use this particular UI to get a sense of how well we are performing, right? So what I'm going to do now is I'm going to go back into my editor. I'm going to make a small tweak to this particular configuration. But before that, I'm just going to format this document as well so that it looks slightly neater. So this was the run that we just created, where we actually generated a bunch of outputs from the 3.5 model. I'm going to just now go and attach a scoring function to this particular model, right? So a scoring function actually takes in the output and does something on that and spits out whether the output passed or failed, right? Now this is an array, which means that I can define different types of scoring functions, and we have a few different options in Empirical, and we'll keep adding more. Now in this particular case, I'm actually going to use a Python script as a scoring function because I'm actually going to take in the output that the LLM generated, run the tests that are there in the dataset, and then see whether those tests pass or not. And I have that file created in this file called score.py, which we'll just take a look in a brief second. But I'll actually just point this configuration to pick up that file. So let's take a look at what this file looks like now. I'm just going to close my terminal window and open score.py. So score.py is basically going to use evaluate as the entry point, where it has a bunch of arguments, the output and the inputs. And what I'm going to do in the evaluate function is that I'm going to actually concatenate the output that I have from the LLM to the test that I'm getting from the inputs. And then I'm just going to run the exec command. The exec command basically runs the given source code. So you're giving source code in the form of a string, and Python is just going to execute that. Now, if this exec function passes without exceptions, that means our test passed. If it does not, if it throws in exceptions, that means our test failed, right? And just to sort of handle that nuance for backticks, I'm just going to, I've written this additional function which basically extracts the code snippet from the given output if it's inside a set of backticks. And the flexibility of actually writing code is great here because I can import something from the Python standard library so that I can actually write a function, a scoring function that is best appropriate for my use case. So this is what a scoring function looks like, and I'm going to go back into our configuration file here, and I'm actually going to make another small change here. I'm going to actually just run this file now on two models. So in addition to running it on 3.5 turbo, let's also run it on GPT-4 turbo, which is available in preview. And we're going to actually pass the same prompt. We can change that, and we're also going to pass the same scoring function, and we'll just stick with this for now. So coming back to my terminal window, I'm just going to do a quick run again. Hit the run command. This will take a few seconds to run. But this is essentially, what I meant with, a fast iteration loop, where I'm able to actually like change a few different things in my configuration. Use the fact that, Empirical as gives me a declarative sort of configuration where I can actually describe the test that I want to run, and then, let it take care of the heavy lifting when it comes to sort of, executing it in parallel, making sure that it, completes quickly, and then showing the results, in a UI. So let's give it a few seconds. Cool. So we have our results here, and we can see that our run was executed on GPT 3.5 Turbo and 4 Turbo Preview. Both models generated 100% outputs, but in terms of the unit test scorer, GPT-4 Turbo actually performed much better, right? It gave us about 88% accuracy, while 3.5 was at 57%. Now, these numbers are actually based on the configuration that I gave here, right? And there might be an opportunity for me to bump up the 3.5 number with, more prompt experimentation that I can actually pick up on this particular UI and just, do another rerun. But for now, we'll actually like see the UI and just get a better feel for, what did we get out of these two sort of, LLMs. So we see a side-by-side comparison now where we can actually see the input on the left. So I'm going to go back to looking at the prompt, and we can see the output from, 3.5 and 4 Turbo. And, here you'll see that my tests failed, and my tests failed because of a very specific reason, which is list is not defined. Right, so we can see here that 3.5 is relying on this particular list keyword, but it's actually not importing that list keyword, which is what GPT-4 did a pretty good job at. Now the tests passed here, but what's interesting is that GPT-4 actually gave us a fair bit of explanation before it could actually like jump into solving the scenario. Now this explanation actually represents certain chain of thought where GPT actually GPT-4 actually got higher accuracy because of this explanation, and our scorer function, because it was able to actually extract the code from within the backticks, took that, ran that, and gave us results for whether the tests passed. Now if you're sort of building on top of an output like this, you might want to be more concerned about the structure of the output, and you might want to like use a bit of more prompt engineering to sort of tweak a few things there. But in this case, we are not concerned about that, and so this is what we have. I can obviously like see more of this, but I'm actually now eager to run this on on some of the models that we saw in this particular sort of table. So we saw 3.5, which gave us about 50-ish%, right, 57%, and GPT-4 Turbo gave us 88%. And these numbers are actually higher than the ones that are reported here. And if you click on this link, it'll actually take you to the GPT-4 technical report, which is a bit dated. So looks like some of these numbers that are shown here are maybe a bit dated, and we're not able to we're able to actually get much higher performance than the ones here without playing around too much with the prompt. But let's try DBRX and maybe also Claude 3 Haiku. Which interestingly does better than the larger model Sonnet. So let's give these models a go as well. And to do that, I just have to sort of make some changes to our config file. So let's actually skip 3.5 for now. I think we've seen enough of that. And I'm just going to make a copy of this. And instead of OpenAI, I'm just going to switch over to using Anthropic and use Claude 3 Haiku. Oops. The same prompt and the same score. And then I'm going to try using DBRX. Now DBRX is an open model, and it needs to be hosted somewhere, right? And for this experiment, I'm actually using Fireworks, which is one of my favorite inference providers, and they have support for a bunch of different open source models, including DBRX Instruct, which was the model that was demoed here. So I'm going to actually use Fireworks for my model provider, and just type in dbrx instruct as the name of the model. Now, dbrx also has some additional parameters. So it sets the temperature at 0 and it sets n at 1. So I can also actually define these parameters here. So I want the temperature to be at 0, and I want n, which is the number of samples that are returned in response, at 1, which is actually the default in this provider, but we can define it explicitly without any problem. Now I'll keep the same prompt, and we'll see how this particular prompt behaves. I'm sure there's a lot of room for improvement by tweaking this prompt around, and then run the same scorer here as well. So let's jump into the terminal, and I'm going to then use our helpful CLI to just issue another run command. Now this will take a few seconds. We're actually running 3 models, so let's give it some time. So there we have it. We ran 3 models. 4 gave us about 85%, which is slightly lower than the 88 that we got in the first run. And so there is some variability. Claude 3 Haiku gave us 79%, which is incredible given the cost and the size of the model. And dbrx instruct gave us about 49%, right? And this again, we did not tweak the prompt, and there might be scope to actually get this to be a lot higher, right? If I go back to the blog post, our numbers from Claude Haiku actually match or are actually slightly higher than what are reported here. But our numbers of dbrx instruct are actually a bit on the lower side, right? And so I'm not really sure what's different, right? In the case where we're running it with the same parameters, but obviously there could be some differences because of where the model is hosted and what the prompt is, and so I'm sure there is a lot of scope of improvement on that front. I can also open the UI just to actually get a more experiential feel for what these results look like. And so all 3 of these actually sort of have a similar response structure. They have a bunch of an explanation on the top, with results in backticks, and I can actually hover over these and see what went wrong with some of these. So for example, here again, list is not defined, so we could potentially solve this with some prompt engineering on the dbrx side, and the empirical UI is basically giving you that side-by-side comparison to give you a sense of what went wrong. This looks like another case where list is not defined. Looks like this is one where list is defined, so looks like we had a bit of a syntax error here. Seems like the function did not complete the backtick. And so, getting this experiential feel actually now gives us a sense of, what should we change in the prompt, right? And that can be a way for us to, basically climb the ladder of just getting better with, each iteration. And, our job as builders of Empirical, of this framework, is to make sure that the iteration loop is actually very fast for you, so that you can actually, just make quick changes, see results, iterate, and get something, get an update and do a side-by-side comparison, between a few different cases. I'd obviously encourage you to check out, our documentation and give us a go. You can obviously try this on other data sets, create your own data sets that are more appropriate for your problem statement, and use this as maybe a reference point. And if you're interested in trying out the HumanEval example, you can go into a repository here, click on examples, and just check out the HumanEval example. So it has the same sort of scoring function, and a configuration file, and a helpful README for you to actually reproduce whatever we were doing here in this particular video. That's it for now. Hope this was useful to actually get a sense of how some of these scientific benchmarks work, and combining some of the systematic nature of these benchmarks with like a more experiential vibe check. And hopefully this encourages you to, make your own benchmarks. And if we can be of use, please do reach out to us. You can leave an issue on our repository, or join our Discord, and we'd love to sort of hear from you. Thanks, and have a good one.